Hello. I hope by now you have watched the course introduction movie and you are familiar with the various components of the course. You know how to access the various course materials and prepare and do well in the course. Well, if you haven't done so, please go and watch the course introduction before you start the course. Now, we will begin this course with a brief description on measurement. Well, once again, welcome to General Physics 1. What does measurement deal with? And what is the significance of measurement in physics? Well, of course, physics is full of measurement. Without measurement, there is no physics. We come across physical quantities all around us. And physical quantities are quantities that we describe by measuring. And in order to measure physical quantities, we need to use a unit. So we will first of all start with a description of units and measurement. All right. When you hear somebody says $5, you know that the quantity measured is money. When somebody says 5 meters, you know that the quantity measured is length. So what does unit of a physical quantity means? A physical quantity is identified by the unit of measure. Once you know the unit, you know the quantity that is measured. Now, we will use the SI system of measurement in this course. What does SI system means? It is the System International. That is the system used all over the world. Unfortunately, America hasn't come in line with the rest of the world about measurement. We still use the old British units. We still measure length in inches, feet, and miles. We still measure mass in pounds and all that kind of units which the rest of the world don't know. Now, we cannot do that in physics. We've got to follow the rest of the world. So we are going to forget about inches, miles, Fahrenheit, and so on, and we will be using SI units. All right. The unit of length in the SI system is a meter. Now, if you watch here, this is a meter stick. Well, it's too big to fit in the screen, is that right? I'm sure most of you have seen a meter stick. The unit of length is a meter, and we will abbreviate it by the small letter m. The unit of mass is a kilogram. Now, do you know how much a kilogram is? Well, I hope I could give it in your hand and make you feel. Well, give me a second. Here I'm holding a standard 1 kilogram mass in my hand. Well, it is a brass cylinder and its mass is 1 kilogram. Well, this is the unit of mass. And how do you represent that? Kilogram is kg, both lowercase. And the unit of time is the second. So the SI system of unit, length is measured in meter, mass is measured in kilogram, and time is measured in second. So very often it is called the MKS system. MKS system. Now, units of length, mass, and time are called the fundamental units of measure. Why are they called the fundamental units of measure? Because almost everything else can be expressed in terms of the units of length, mass, and time. The units of all other physical quantities can be obtained by suitably combining these fundamental units. Now, meter is the unit of length. We talked about it. Now, if you look at this meter, this is the meter stick. Now, can you use this to measure the width of a hair? Well, I got to look for my hair. I got a few out here. If I take one of my hairs and I want to measure the diameter of my hair, can I use a meter stick to do that? Well, obviously, we need to divide this big meter stick into smaller parts. And you can see it is actually divided into smaller parts. Is that right? Now, a meter stick is divided into 100 centimeters, and each centimeter is divided into millimeters, and so on. Let's look at some of these divisions. So how do we use units in order to measure large distances and small distances? Now, look at the terms that we will use. We will start with the meter. And now, I'm going to take you to the left. To the left of the meter, we have units that are used in measuring small distances. And I'm going to say meter is 1 unit. Is that right? 1 unit. And I wrote it 10 to the power of 0. And 1/10 of a meter is called a decimeter. Look at this, 10 to the power of -1. 1/10 of a meter. 1/100th of a meter is called a centimeter. So how many centimeters are there in a meter? A centimeter is 100th of a meter. That means there are 100 centimeters in a meter. How about millimeter? A millimeter is 1,000th of a meter, 10 to the power of -3. A micrometer is 1,000,000th of a meter, 10 to the power of -6. A nanometer is 1,000,000,000th of a meter, 10 to the power of -9. And how about picometer? Is 1,000,000,000th of a meter, 10 to the power of -12. Well, I will show you how to write these. Centimeter is lowercase cm, millimeter is lowercase mm, micrometer is the Greek letter mu. I will show it to you as we go on. Mu m, nanometer is nm, and so on. Alright, so these are the units for measuring very small distances. Let's now go for large distances. What does deca mean? What's a decade? A decade is 10 years. A decameter is 10 meter, 10 to the power of 1. A hectometer is 100 meter. A kilometer is 1,000 meter, 10 to the power of 3. A megameter is 1,000,000 meter, 10 to the power of 6. A gigameter is, what do you think? Is 10 to the power of 9 meters, which is 1,000,000,000 meter. And finally, a terameter is 1,000,000,000,000 meters. So we have now units that are used for measuring very small distances and very large distances. Similar measures are used for measuring small and big masses. You know, in measuring mass, what is the unit for measuring mass? It's a kilogram. So in place of meter, we will write a gram. And gram is a G. Gram, decigram, centigram, milligram, microgram, and so on. Decagram, hectogram, kilogram, that's our unit, megagram, and so on. So we can use the same quantities, same terms for measuring mass as well. Now how about measuring area, volume, speed, density, and so on? These are examples of physical quantities that have units that are derived from the fundamental units. So in order to obtain the units of area, volume, speed, density, and so on, we combine the units of the fundamental quantities. Therefore, the units of such quantities are called derived units. Derived units. They are derived from the fundamental. For example, the area, the unit of area. Now, what does area? How do we calculate the area of a piece of paper? Length multiplied by length. Length is measured in meter. Width is measured in meter. Therefore, area is measured in meter multiplied by meter, which is a square meter. Similarly, the unit of volume is a cubic meter, meter cube. What is the definition of speed? Speed is the rate at which distance is being covered. Is that right? That is distance divided by time. So what is the unit of speed? Distance is measured in meter. Distance is in length. Time is measured in second. So the unit of speed is meter per second. Meter divided by second. And look at the way we write it. The standard way to write this is meter times second to the power of -1. So we will not write units like this. We will write units like this. Meter second to the power of -1. Density. Does anybody know how density of an object is defined? Density is mass contained in unit volume. And you can measure density by dividing mass by volume. Mass divided by volume is density. Well, what is the unit of density? The unit of mass is the kilogram. Unit of volume is the meter cube. So unit of density is kilogram per meter cube. And can you tell me how do we write it in the standard form? Well, we write it in the standard form as kilogram times meter to the power of -3. Now this is the standard way we will write all units.